Okay. Okay, sir. Can you see my screen now?
হ্যাঁ দেখতে পাচ্ছি।
Okay, sir. Okay, so previous class we also try to discuss about that proof classification using the ground truth data set. Okay, in Google Earth Engine platform, how we can easily perform. But this time, when I want to apply this model, we can get the very low accuracy, such as 60% accuracy and 66. This type of accuracy we can get. So in this time, I also try to discuss about that, how we can easily calculate it and also increasing the accuracy of this classification map. Okay, so we must be more than good accuracy for get the better result for classification. So in this time, I talk about that, how we can easily improve the accuracy of this map. Okay, so basically different way we can easily do for increasing the accuracy. First of all, if possible, then we can simply go to the field again and also take the more training point for the different types of crop. So this is the one, and another one is that we need to also increasing some band. So in this classification, we are using only for those band which band are available in our satellite images. For Sentinel-2, all of the band already available in here. Okay, so mainly all of those training point mainly struck only for those values which band I want to set in here. But if you want, you can also add here some other external band, such as we can also add here the NDVI band. Also we can use here the, suppose we can also use here this band such as NDBI. Also we can use here for MNDWI band. We can also use for uh, bare soil index band, BSI index. Okay, so all of those internal band, which when we want to add in here, then all of those training point for also struck all of those band value. Okay, so then when you run our model, then we can also get the better accuracy. Because suppose mustard and rice, this NDY value we can get very low difference. Okay, so all of those difference also clear classification for this. Okay, so in this time I also try to show you that how we can easily create some external band such as NDVI, NDBI, MNDWI, then BSI, this type of index, how we can easily add and also increasing the accuracy. So in this time we can get the 66. Okay, so and when I use this all of those band, external band, then what accuracy I can get in here. Okay, so let's go how we can easily do that for external band. Okay, so in this time we need to create this all of those external band and then add in here. And this band B1, B2, B3 already available in our satellite images. Okay, so for that, write the code in here. So I take a variable, suppose, okay, in here. Suppose take a variable, add indices. Okay, I take a variable and then make a function. Okay, in this function I create the band, all of those band which I want to need. So I simply put here this image element name and also put the curly bracket. In this curly bracket I put my all of the argument. Okay, my argument in this time I want to create NDPI, NDVI, MNDWI, BSI, this type of band I need to create. Okay, okay, so for that I take a variable and put the variable name, suppose NDVI. Okay, and then call my element name image and simply use a function normalized difference. And in this time normalized difference for NDVI This formula is that near infrared minus red divided by near infrared plus red. And when I use this function normalized difference, it automatically calculated. I simply put this near infrared B8 for sentinel 2 and red B4. Okay. So when I want to use this function normalized difference, it automatically calculated B8 minus B4 divided by B8 plus B4. Okay. This function automatically created. And let's put this band name. Suppose I put the rename and put this name such as NDPI. Okay. And then also take the another variable, suppose NDPI. So mainly it is the normalized difference build up index. Okay. And build up index, this formula is that if you want, you can simply search in the Google. All of the formula you can easily get in here. Suppose NDBI formula, NDBI index formula. I simply search here. So here you can get the formula is that normalized difference. It is the short wave infrared minus near infrared divided by short wave infrared plus near infrared. So you need this short wave infrared and near infrared band. Okay. So for that, I simply use that. So I simply call my element name image and use that the normalized difference. Sorry. Normalized difference in this time short wave infrared and near infrared. Okay. So for sentinel B11 and also B8 for near infrared. Okay. Then it automatically calculated short wave infrared minus near infrared divided by short wave infrared plus near infrared. And I rename it as a NDBI. Okay. Then also take another variable. Suppose I want to calculate it for the MNDWI. So what is the formula of the MNDWI? You can simply search here MNDWI. Okay. So MNDWI formula is that green minus short wave infrared divided by green plus short wave infrared. Okay. Green and short wave infrared. Okay. So let's go. We try to add this band. So take a variable MNDWI and call the element name image. Use here the normalized difference. Sorry. Normalized difference. In this time, I need green and short wave infrared. Okay. So put here the green B3 for sentinel 2 and short wave infrared is that B11. So B11 and rename it. Keep this name such as MNDWI. Okay. Suppose in this time, I also need another index. It's called the bare soil index or BSI index. So just I simply search here BSI index formula. Okay. Okay. So this is the BSI index formula. You can see the bare soil index. This formula is that red plus short wave infrared minus near infrared plus blue. Okay, then divided by red plus short wave infrared plus near infrared plus blue. So this is the formula. Okay, so in this formula you can see it is the combination of more than two band. It has red band, short wave infrared band, near infrared band. Okay, so in this time I don't use this normalized difference function. Okay, so normalized difference function is only work when you want to work for two band. Okay, but in this time you can see this formula created more than two band. Okay, so in this time I need to use expression function. Okay, use the expression function and then use it. Okay, so for that same process, any index we can easily create. Suppose take a variable, suppose BSI, bare soil index, and call the element name image and use the function expression. Okay, expression. And in this time, I put this expression. Okay, so expression is that our formula. So just I simply put this formula. Okay, so just I simply copy this formula. Just copy from here and paste. Okay, and then use at the curly bracket. In this curly bracket, I need to define what is red, what is short wave infrared, what is near infrared, what is blue. Okay, I need to define it. For that, I can simply use here the red, the uppercase red, red. So just I simply call this red. Okay, and I need in this time I want to put this value. So what is the red? Red is come from this image and it select the band red. Okay, so just I simply put this red band, select B4. Okay, B4. B4. After that, we also need to define here what is the short wave infrared. So just use here the SWIR, this variable call, and use here the image and use here the select function and call short wave infrared. So short wave infrared is that B11. So use at the B11. Okay. Then call near infrared. So use at the near infrared NIR. And now define what is the near infrared. Image dot select this band number of near infrared. It be 8. Okay. And then after the near infrared, we can use at the another band is that blue. Okay, what is the blue? So use call the blue and put here this blue band name such as image and select the blue band B2 for sentinel. Okay, so now it's okay. So now I also put this rename it. So I just simply use here the rename function, rename, and put this name such as BSI. Okay, so now I created this band also. And if you want, you can also add here the another types of indices such as EVI, NDVI, any types of indices you can easily add. And finally, we need to use here the return function. So return this image and add bands. So in this time, I'm going to add the bands. First of all, NDVI. Okay, then also add bands NDVI and also add bands for MNDWI. Also add bands for BSI. Okay, so in this time I create the total 4 external band. So just I simply put their band name in here. Okay, so now it's create. This function is created. Okay, now this function is add with my image. Okay, so in this time, this is my all of this external band I created. Okay, and in this time I want to add all of those things with my image collection. Okay, so basically in this time you can see this image has only available this image set. You can say simply print this image and click to the run, and I can get only for those images which images are available in satellite image. Only 16 band I want to get. Okay, but in this time I also created some other external band such as NDVI, NDBI, MNDW, and BSI. So now this other 4 band I also need to add with my image. Okay, this image I want to add with this. Okay, so for that I can simply so I simply take a variable. Suppose take the variable same image, and then I use here the add indices. I simply call this variable name, this variable. Okay, simply copy the variable name and use here add indices with this image. So just put here this image. Okay, so now I also print this. Simply print this image and check again. Okay, so now you can see rest of the 4 band also added in here. So now we can get total 20 bands in here. Okay, if you want to check all of the 20 bands, you can see I added here the ND, VI, NDBI, MNDWI, BSI. So other external band also added with my image. Okay, so now I want to easily use this and also make this classification. Okay, so for that I can simply go to this band. You can see this band. So in this time I want to add here this all of those bands which I create. So for that simply put here this band such as NDVI. Also add here NDBI. Also add here and MNDWI. Also add here BSI. Okay, so now all of those training point which I go to the field and take the training point for the some crop, mustard, then also rice and vegetable, and also we can take the training point from the satellite images for the build up, barrel land, water and vegetation. So all of this training point now extract all of the band value, okay, which I created in here NDVI, NDBI, MNDWI, BSI, and also extract all of those band values, extract and make the data set. Then this data set divided and also make the classification. So now you can check what the accuracy you can get after run. Okay, it's working. Okay, so now we can get this overall accuracy also increasing 68. Okay, when I want to add all of those band and run this model, we can see that this accuracy is also increasing for the 68% accuracy we can get. And without that, how much accuracy I can get, you can check again. So just I simply remove all of the band from here. Just remove from here. Give to the run. Just a minute, it's check the okay. So the better accuracy now. Okay, just a minute. I think some networking issue or other things. Okay, 66. Okay, we can get the 66. And when I want to add this band, we can get the 68. Click to the run again. So I simply copy the link from here and open a new browser again. Some networking issue. Okay. So now it also showing here again 72% accuracy after adding all of those band in here. Okay. So I think the first time it also some networking issue that's why all of those band value is not loaded from the server. So that's why it showing this the same accuracy. But in this time we can get this 72% accuracy after adding the NDVI, NDBI, MNDWI, and BSI index in here for some external band. Okay. So it also increasing the accuracy. Okay, so this is the one method to increasing the accuracy. We can easily add the different types of index, not only for this. In this time I only add here the some indices. Okay, so in this time if you want you can also add here this, suppose EVI index, NDWI index. So a lot of index is available, and some index are closely related to the agriculture field or other things. Suppose I will simply search there. So this is the one type of the VRI index. Okay, so you can take it. So lot of index are available. These are closely related to this the NDVI or agricultural land. Okay, you can see the NDVI, normalized vegetation index, VRI, RECI, EVI2, leaf area index. Okay, WDRVI index, GNDVI index, GCI index, RCI index, NDWI index. So all of these index are closely related to the agricultural land or other things. So when I want to get the more accuracy, then we also add here the EVI, then GNDVI, green normalized difference vegetation index. So then we can also get the better accuracy, and you can use the same process for add any types of indices. Same process we can apply. Okay, when we can get only for those two band in our formula, just use here the normalized difference, and when we can get the formula more than two band, then we can use here the expression. Okay, and after adding this formula and in the same process, after that we can easily add here this all of the band name in here, and run our model, we can check the accuracy, we can get this accuracy increasing than previous time. Okay, so anyone any question? Hello?
আসলে ইন্ডেক্স গুলা যোগ করলে একুরেসি বাড়ে কেন, মানে
বাড়ার
মেকানিজমটা
কারণ
কি?
হচ্ছে মূলত আমরা প্রথমে যে ডেটা সেটটা তৈরি করছি, এই ডেটা সেটটা শুধুমাত্র ছিল আমাদের ব্যান্ড ভ্যালুর উপর ভিত্তি করে হয়েছে। মানে আমরা সাপোজ একটা মাস্টার বা হচ্ছে আমরা একটা এগ্রিকালচারের ল্যান্ড নিয়েছি, এই ল্যান্ড থেকে শুধুমাত্র ওই যে ব্যান্ডগুলো আমরা সেভ করছি B1 B2 B3, এই ব্যান্ডগুলোর ভ্যালুকেই সে শুধু কাউন্ট করছে। আমরা যখন এখানে এনডিভিআই অ্যাড করব বা আদার ইন্ডাইসেস গুলো অ্যাড করব, তখন সে কি করবে, ওই ট্রেনিং পয়েন্ট গুলো থেকেও ওই এনডিভিআই ভ্যালু এক্সট্রাক্ট করবে, এমএনডি ডাব্লিউআই ভ্যালু এক্সট্রাক্ট করবে, এবং তখন আমরা আরো মানে ক্লোজলি মানে ডিস্ট্রিবিউট করতে পারবো। সাপোজ এটা হচ্ছে রাইসের এনডিভিআই, সবগুলো রাইসের এনডিভিআই একখানে জমা হবে, সবগুলো মাস্টার্ডের এনডিভিআই একখানে জমা হবে, সবগুলো রাইসের ইভিআই একখানে জমা হবে। ওকে, সবগুলো জমা হলে একটা বড় ডেটা সেট তৈরি করবে। মূলত আমরা প্রথমে যে ডেটা সেটটা তৈরি করছি সেটা শুধুমাত্র ছিল আমাদের B1, শুধুমাত্র এই কয়টা ব্যান্ডের নিয়ে তৈরি হয়েছিল। বাট আমি যখন এখানে এনডিভিআই অ্যাড করলাম, তখন কি করবে, আমাদের সবগুলো ট্রেনিং পয়েন্টের ক্ষেত্রে এনডিভিআই এর ভ্যালু কত সেটা বের করবে, এনডিভিআই এর ভ্যালু কত সেটা বের করবে, এমএনডিডব্লিউ এর ভ্যালু কত সেটা বের করবে, এবং একটা পরিপূর্ণ ডেটা সেট তৈরি করবে। এখন যেহেতু এখানে ডেটা সেট গুলো বেশি আসতেছে, এখানে এনডিভিআই ভ্যালু, এমএনডিডব্লিউ এর ভ্যালু, তখন সে আরো ভালো করে ক্লাসিফিকেশন করতে পারবে। এরকম অনেক ইন্ডেক্স আছে যে ইন্ডেক্স গুলো দ্বারা মানে এক্সটার্নাল ইন্ডেক্স গুলো ইউজ করার মাধ্যমে কোনো একটা মডেলের অ্যাকুরেসি বাড়ানো যায়। আর অ্যাকুরেসি যত ভালো হবে, আমাদের ম্যাপটা ততই অ্যাকুরেট হবে, এবং তার যে আমাদের যে এরিয়া গুলো রয়েছে মাস্টার, এই এরিয়া গুলোও তত ভালো আসবে আমাদের ম্যাপের ক্ষেত্রে।
আচ্ছা, এই ইন্ডেক্স গুলা যে তৈরি করা হয়, ধরেন বিল্ড আপ এরিয়া ইন্ডেক্স যেটা, এটা কি আমরা যদি ইউজ করি আমাদের স্ক্রিপ্টে, তাহলে যে সেটেলমেন্টের ইয়ে চলে আসবে না অটোমেটিক অ্যামাউন্ট?
চলে আসবে। যেমন বিল্ড আপ ইন্ডেক্সের ক্ষেত্রে হাইলি পজিটিভ ভ্যালুকে কনসিডার করা হয় আমাদের সেটেলমেন্ট হিসাবে।
হুম
আর
হুম
যেগুলো হচ্ছে লো ভ্যালু বা নেগেটিভ,
হুম।
এগুলো হচ্ছে আমাদের হতে পারে ভেজিটেশন, হতে পারে এটা গাছপালা, এই টাইপের কিছু।
সেক্ষেত্রে যদি আমি শুধু আপনার সেটেলমেন্ট নিয়ে কাজ করতে চাই, তাহলে তো আমার এই ইন্ডেক্স নিয়ে কাজ করলে হবে, এখানে আমার কোনো ট্রেনিং পয়েন্ট দিয়া এটা আলাদা ক্লাসিফিকেশন করা লাগবে না, তাই না?
না, মূলত আমরা ক্লাসিফিকেশন করি, এটার মূল উদ্দেশ্য হচ্ছে আমরা যখন মেজারমেন্ট করতে যাব,
হুম।
ইন্ডেক্স দিয়েও মেজারমেন্ট করা যাবে, তখন আপনাকে একটা থ্রেশহোল্ড ভ্যালু ধরতে হবে। সাপোজ আমি চাচ্ছি যে 0.5 এর উপরে যেগুলো থাকবে সবগুলো হচ্ছে বিল্ডিং, এখন 0.5 এর উপরে কতগুলো পিক্সেল ভ্যালু আছে ওই হিসেবে কাউন্ট করে আমাদের বের করতে হবে।
আচ্ছা আচ্ছা, বুঝতে
আর
পারছি।
ক্লাসিফিকেশন করলে আমরা ডাইরেক্ট এভাবে ক্লাসিফিকেশন করলাম, এটা বিল্ড আপ, এটা এগ্রিকালচার, এটা হচ্ছে ওয়াটার, করে আমরা জাস্ট এইভাবেই আমরা মানে ক্যালকুলেশন করতে পারবো। তারপর সেপারেটলি সেম নিয়ম, আমরা যদি সেপারেট করতে চাই প্রতিটা ফিল্ডকে, যেমন সাসেস মাস্টার দিস ভ্যালু ইজ 0, তো আমরা আমরা দেখাচ্ছি যে মাস্টার্স গুলোকে আমরা দেখাচ্ছি যে ইয়েলো কালার। তো ওকে, তো এটা হচ্ছে আমাদের মাস্টার, রাইট দিস লেয়ার নেম। দেন রাইসকে আমরা দেখেছি গ্রিন কালারে, সেপারেট করেছি। ভেজিটেবল